call us again for any surgery or any small thing. Uh, they would put sutures, and they'd ask after 3 or 4 days, come, we'll take away the sutures so that the skin gets, when the skin is set, that is the cut is gone, they'll just take away the sutures. Now, how come they're not taking away the sutures? Now they have a biodegradable material. That means suture gets dissolved and will actually combine with the body. Okay, all because of thanks to the new set of polymers which are available for umpteen applications, including medical. Okay, so now nowadays, in because we are watching a lot of TV, we are having all these eco-friendly products nowadays. Organic foods, eco-friendly products are now very much happening. They are the stylish things, items to be purchased as per the demand of the day. Now, what are these biodegradable materials? We are seeing that the fibers of these banana trees and all are now being very exclusively used for making disposable glasses, disposable plates, what we'd be using in day-to-day life. Okay, this use and throw plates and glasses are now made up of banana fibers, and it needs products. A very patented one from our country, finding umpteen applications abroad. It seems nowadays they are making so many biodegradable materials, which are actually can be consumed. Like it seems in few places, few restaurants abroad, they are having spoons which you can eat straight away. After eating the food, you can eat the spoon as well. It seems I think it's very tasty. I don't know. Could be. And if by chance you don't want to, you want to throw it away, still it is a biodegradable material. So by this time, in your EVS, probably you might have studied what it means by biodegradation, what it means by biodegradability. You know it? What you have studied in your EVS? Hello? Hi. Okay. EVS class, you don't like chemistry? So I can ask you questions straight away, even in EVS, which are very much important for me to conclude this polymers topic. I have a question for you. Now, which energies we are relying on? Conventional energies or non-renewable energies or renewable energies? Roll number అడగండి చెప్పరా? ఏది ఏ ఎనర్జీ వాడుతున్నావు? రెన్యూబులా నాన్ రెన్యూబులా? అమ్మ బాబాయ్. హలో,
రెన్యూవబుల్ మ్యామ్.
రెన్యూబుల్ ఎనర్జీస్. ఎందుకు? వాట్ ఆర్ రెన్యూబుల్ ఎనర్జీస్?
వాటర్.
What are renewable energies? What are, give examples of renewable energies? Come on, boys and girls.
Sun.
Height. ఏంటి?
Sunlight.
Sunlight is an example. And renewable అంటే ఏంటి? Renewable అంటే ఏంటి?
సోలార్ ఎనర్జీ.
ఏంటి?
The energies which doesn't exhaust, ma'am.
Yes, the energies which do not exhaust. Hello, come on, kids. Please realize yourself that if you are not learning these things properly, take it from me, you are supposed to be less graded than others. Don't feel angry that I'm telling you this. ఎందుకంటే ఈ ఏజ్ లో మీరు you should have that versatility to give fun chances. If you think something is not interesting, then how about you? Are you an interesting individual? How you are making yourself interesting? ఈ జీకే నాలెడ్జ్ చాలా చాలా ఇంపార్టెంట్ మీ అందరికి. అండ్ ఎలక్ట్రానిక్ స్టూడెంట్స్ ఆర్ ఆల్సో. ఈ వేస్ట్ is one thing which is actually again a huge environmental problem, is it not? today's problem is e-waste. Robo 2.0 అవన్నీ ఉన్నాయి కదా. Okay, now lot of research is on actually how to get rid of this e-waste, and you'll be surprised, lot of scope abroad with respect to this new innovative technologies they want to bring in. అంత ఈవీఎస్ అనే చాలా మంది స్టూడెంట్స్ చూస్తా, ఈవీఎస్ ఓ నథింగ్ అనుకుంటారు, బట్ యాక్చువల్లీ దేర్ ఈస్ ద మోస్ట్ ప్రాక్టికల్ థింగ్. విల్ బి సర్ప్రైజ్, మీ సిలబస్ లో ఏముంటుంది తెలుసా? వాట్ ఆల్ కాన్సెప్ట్స్ ఆర్ టీచింగ్ యు ఆర్ ఓన్లీ బేసిక్స్, but if you go around the world and really find your application, then you'll be surprised that you'll be working on such things which you have already neglected. ఏదో పిచ్చి సబ్జెక్ట్ అనుకున్నదే అదే ఇంపార్టెంట్ అయిపోతుంది. Okay, but let me get back. What's the difference between biopolymers and biodegradable polymers? Listen to my question. What is the difference between biopolymer, biodegradable polymer, and recyclable polymers? Tell me. So what's your answer? Huh? What are biopolymers? Give examples. Hello? What are biopolymers? What are recyclable polymers? Ramachandra.
Polymers which can be recyclable, ma'am.
Examples?
PVC, ma'am. PVC.
Okay, thermoplastic polymers, correct? Why you're always silent? Huh? Why you're all silent? You're taking a nap? It seems it's a common thing they'd say. Ammo time అయిపోతుంది, నేను ఇంకేదైనా మాట్లాడాలంటే. That it seems our former Prime Minister, Mr. Atal Bihari Vajpayee, is actually very known for his very oratory skills. It seems right in UN and all, always used to play a very key role representing India in UN. And he would always say, it seems, that post-lunch sessions are graveyard sessions. అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ మన అక్షయ్ అన్నాడు 61 రోల్ నెంబర్, అలా నిద్ర వచ్చేస్తుంది, అసలు నువ్వు అనుకో, అలా నువ్వు అనేసరి నీ కళ్ళు మూసుకుపోతాయి. చాలా కష్టపడిపోతున్నారు కదా మీరు. మై గాడ్, హౌ మచ్ టైర్డ్ యు ఆర్ listening to all important classes right from the morning till afternoon and have food. Obviously it's not an easy thing. I'm not bragging you, it's a fact. The eyes would just slowly take a nap if the session is not very involving you. Okay, so post lunch sessions are very, very tough to handle actually. Okay, you might have slept like that in the EVS class. So small questions you are not able to answer that should be your deal. Okay, I'll get back. So what's the difference between biopolymers, biodegradable polymers, and recyclable polymers? Hope you know this. Okay, this symbol we'll be seeing, and there are numbers there, 1 2 3 4 5 6 7, like that.
The 3 R's principle.
Huh?
The 3 R's principle, ma'am.
3 R's principle, you know that?
Yes, ma'am. Reduce, reuse, recycle.
Huh? What? Get back.
Reduce, reuse, recycle.
Reduce, reuse, and recycle. And there is one more thing. This shows, first arrow shows the collection. Second arrow shows the recyclization. The third arrow shows reusage. Okay, these are the 3 arrows, and the number in the center shows the polymer that is being, or the plastic that is being recycled. One stands for, I think, for PP, polypropylene. like that. They have 7 numbers. Okay, and they'll tell whether the plastic that is recyclable or not. What you should always remember is that whatever is being recycled is generally a thermoplastic material. Whereas I've already told with you, the nonsense materials which cannot be recycled are thermoset polymers. So we'll just burn it away, leading to the pollution of the environment. Okay, and that is the problem. Why the problem with e-waste? E-waste has the main fabrication, the bodies of many e-waste materials are made up of thermoset plastic materials. Okay, and hence the recyclization has become really difficult. Okay, okay, that topic we have discussed. Now, what are biopolymers? The polymers that are present in the life forms. Okay, like DNA, RNA, like that. Okay, proteins, etc. The macromolecules that are present in the body of living systems are all biopolymers. Because these polymers are present in the biological systems, they are called as biopolymers. Now, what are biodegradable polymers? Biodegradable polymers are polymers which are degraded either by environmental conditions like sunlight, or by the gases that are present in the atmosphere, the temperature changes happening, and by bacterial action. So, polymers which undergo degradation due to the action of environmental conditions and action of microorganisms are called as biodegradable polymers. Okay, these are synthetic polymers like the polylactic acid, very famous. Okay, this polylactic acid is actually man-made, but when it is left like that, that polymer undergoes degradation due to the interaction with the atmospheric conditions, and hence is an example of a biodegradable polymer. Okay, so the heading, write the definition. Biodegradable polymers. These are polymeric materials. These are polymeric materials which can undergo degradation. These are polymeric materials which can undergo degradation they undergo degradation due to the action of environmental conditions environmental factors like sunlight, change in temperature, interaction with gases, atmospheric gases, and also microbial action, and also due to microbial action. Like bacteria, fungi, algae, etc. Action of bacteria, okay, are all supposed to be biodegradable polymers. Examples include polylactic acid, polyvinyl alcohol. Example, polylactic acid, P, capital P, capital L, capital A, polyvinyl alcohol, PVA, polyvinyl alcohol, various polyesters, etc. Polyesters, etc. are all examples of biodegradable polymers. I think I have sent you notes. Please, did you check with it? Locates, did you check with the notes? In the group, I've sent the entire syllabus notes. Please realize that. Okay? Okay. I'll get back. Fine. So, next point. What you have in your syllabus is polylactic acid. So, I'll just focus on it right now. Right. Now, how these biodegradable polymers can be? It can be natural polymers or synthetic polymers. As polylactic acid is a synthetic polymer, but are the living systems biodegradable? Yes, very much biodegradable. So, biodegradable polymers can be of how many types? They can be natural, they can be synthetic. Okay. So what are natural polymers? Like the proteins. Proteins example wool, silk, cotton are examples of proteins, or they can be polysaccharides or carbohydrates, polysaccharides like cellulose, starch, etc. Now they can also be various other materials. Even the biopolymers can be natural, or they can be natural gums. Okay, the natural gums like shellac. What are natural gums? Lacca. Natural gum or adhesives. Adhesives like shellac. Shellac ante lacca. Okay, natural rubber. Natural rubber are all examples of biodegradable polymers which are present in nature. Okay. Now I'll move to the next category, synthetic biodegradable polymers. Now what are the synthetic biodegradable polymers? They are man-made, but they are biodegradable, like the polylactic acid, polyvinyl alcohol, okay, polyesters, not all, few polyesters, okay, polyesters, etc., all fall in this category. Or you can say polyhydroxy compounds. Or commonly, the research is native, actually not much. Okay, it's a very nascent research that we have started using this biodegradable polymers, and the synthetic still not much applications nowadays. We are increasing the number. It's a happening work. Okay, right. Now what is important to you is polylactic acid. Right. Polylactic acid, preparation and few properties are important. Okay, I'll quickly conclude. Simply not 2 marks question is asked, so let me not be fussy. The idea is polylactic acid. It is called by abbreviation PLA. Okay. First point is synthetic. Synthetic biodegradable polymer. Synthetic biodegradable polymer. Second point is available in two optically active isomers, isomeric forms. Two optically isomeric forms. Glucon D or glucon L. Which will drink? D small l is optical activity. Dextrorotatory and levorotatory to light. It is possible only when there is a chiral center at the carbon. That means carbon attached to 4 different functional groups. I'll not D and L isomers. Okay. D is PDLA. This isomer is PDLA and this isomer is PLLA. Okay. Lack of time. I'm sorry, but I can't help it. I have to focus on what is there in your syllabus. Okay. Next point. It is thermoplastic in nature. Thermoplastic in nature. Used as can be fabricated. That's better. Can be fabricated as fibers, or it can also be made into films or sheets. That's a beauty, etc. That's it. Okay, can be fabricated into fibers, films, and sheets. Obtained from natural sources. It is obtained from natural sources like cornstarch, sugarcane, tapioca, PIO, tapioca, etc. You know what is corn? Corn తెలుసు కదా. ఓకే, షుగర్ కేన్ కూడా తెలుసు. టోపియోకా అంటే తెలుగు తెలిసే యూ హ్యావ్ దట్ సాబుదానా, సగ్గుబియ్యం. Okay, it is made from, the origin of that is I should say pendulum, they'll say. That's the origin. Tapioca. It's called tapioca. Okay. Did you take it out in your notes? Right. Now write preparation. Actually, the monomer, the structure of lactic acid. All right. Structure of lactic acid. Structure of lactic acid. Okay. It is, this carbon is a chiral carbon. I'll put a star. Okay. You have CH3H. Okay. And you have OH and COOH. Okay. And there is a possibility of D and L lactic acids. Okay. Depending upon the position of OH. Now this has the first member. I hope you know. This has the second member, and that has a third, and this is 1. Okay. The major highest number is on which side gives whether it is L or if it is on the right it is D. Okay.
Ma'am, we cannot see
D
the
or L
structure.
lactic acids are available. Okay. Not able to see the board. Fine. So that's the one. Right. Preparation. Starch. Preparation. You'll take starch from corn, sugarcane, or tapioca. You take starch from corn, sugarcane, and tapioca. Okay, and that starch will be actually fermented. Fermentation for bacterial action. Okay, bacterial action. ఏం చేస్తాం ఫర్మెంట్ చేస్తారు చేసి బ్యాక్టీరియల్ యాక్షన్ అయిన తర్వాత you'll get lactic acid. Okay, OH, COOH, H. It can be D or L lactic acid. Anything is available after fermentation. Okay, D or L lactic acid. Both isomers you'll get after fermentation. Now, if I polymerize this, what will happen? It will result in a very low molecular weight polymer, which is not useful for any application. So, what you will write? Monomer. No, this is not the monomer. What you will write? Lactic acid molecule is not polymerized. Lactic acid molecule is not polymerized. Why? Because a low molecular weight is not polymerized since a low molecular weight polymer is obtained. Low molecular weight polymer is obtained. Therefore, ante. Therefore, chalu. It is of no use. So, what you'll write? This lactic acid is dimerized, which acts as the monomer. Dimerized. And the dimer is monomer. Dimerized to get the monomer. To get the monomer. The dimer is, you'll write a benzene ring. Shall I rub the board? I'll rub the board. Hope you have understood this. It's all there in the notes. Okay. So, what I was like trying to tell you all, the starch which I have got from the corn and sugarcane and tapioca is fermented for bacterial action. Fermentation is done by bacterial action to get lactic acid. That lactic acid I get, the single molecule is not a monomer. Why? If I polymerize that single molecule, I'll get a very, very low molecular weight polymer, which is of no practical use. Okay. So what I'll do, I'll dimerize lactic acid and the dimer acts as the monomer. Okay. So I'm writing. So what I'll do, I'll take lactic acid, CH3H, OH, C double bond O, OH, plus one more lactic acid, CH3H, okay, OH, C double bond O, OH, okay, there is removal of water, okay. Now what will happen? You're not able to see the board. Sorry. Now that's two lactic acid molecules from which water is removed. Okay. Water is removed. Minus H2. Okay. Now what I will get is a dimer. How I will write the dimer? Just this one thing you just concentrate. I'll write the dimer like this. Okay. This will form a cyclic anhydride. Cyclic anhydrides are called as lactones. Cyclic amides are called as lactams. Okay. This will form a cyclic anhydride like this. Ela rayali the dimer idi lactic acid. Idi lactic acid. Okay. And I am writing the dimer after removal of water. Okay. How? Just look at the board. I'll make an hexagon. Okay. Now this C double bond O groups of these two lactic acid molecules are placed opposite. Okay. Now this C double bond O are linked to oxygens. So besides this C double bond O, I'll write oxygen here and oxygen. The two oxygens should be diagonal. Okay. Both should be diagonal. Now this O is followed by another carbon CH3H. Now this is cyclized structure and it is a catalyzed reaction HCH. Now this cyclic compound is nothing but the monomer. It is called dilactide and it is the monomer for polymerization. That is a monomer for polymerization. Okay. Now this undergoes polymerization to form polylactic acid. Polylactic acid. PLA. And that undergoes polymerization. How come the board is only partially visible? This dilactide gives polylactic acid. Okay. Fine. PLA. What's the structure of polylactic acid? Structure of polylactic acid. I'll write the structure here. So structure of polylactic acid, PLA, is like this. Now that undergoes a ring opening and it will form a polymer like this. How? Please understand how to write the structure. Now make those three hills like that. Okay. And what you'll write here? C double bond O. Okay. O. C double bond O. O. CH3H. H. CH3H. H. And taken in times. That's the structure of PLA. Okay. I think it's already 3. Now quickly I'll conclude. That's the structure of PLA. Okay. So I hope you understood. What's the difference? I've just now told you. What are its properties? This is a thermoplastic material which is biodegradable. It is made into fibers, sheets, films, etc. Okay. It is very much, I should say, stable towards heating. What will happen if you heat this? That means, can you heat polylactic acid? Yes. But its stability is in the temperature range of 60 to 190 degrees centigrade. Okay. And generally, both the isomers, that is dextro and levo, D and L isomers are mixed so that you'll have more temperature resistant polymer. Okay. As such, its melting point is around 173 to 178 degrees centigrade, and its glass transition temperature is between 60 to 65 degrees centigrade. What it means by glass transition temperature, like I was trying to tell you all that, um, when you are heating a polymer, because it's a macromolecule, it is not melting at a particular temperature. Initially, it goes into a translucent state, okay, a semi-solid structure state where uh, it is called, it gives a very murky appearance, okay. That semi-solid mass which is obtained is nothing but a translucent material, and the temperature at which it attains that state is called as glass transition temperature. That is 60 to 65 degrees for polylactic acid. But it clearly melts between the temperature range of 173 to 178. Okay. And its heat deflection temperature. What it means by heat deflection temperature, the temperature at which this undergoes physical deformation on heating is 60 to 190 degrees centigrade. That's a huge range actually, that it is stable, that under load also it is stable. Okay, so that's a property of polylactic acid. What are the applications? Generally, it is finding applications in medical industry and also for consumer durables, like consumer materials like the plastic plates, uh, the use and throw materials and all. It is finding applications, carpets and all. Domestic applications, that is consumer applications, it is finding wide applications. Along with that, it is used in medical industry, particularly for surgeries and all. That concludes the polymers topic. Okay. Why I have not given notes for this polylactic acid is, it's there included in your notes. Okay. Fine. So that's it for the day. So I'll take attendance, and on Friday, sharp join by 10 o'clock so that I can start with the batteries. That's again important and interesting as well. Okay. 61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64,